Today we're going to cover chapter 14.1, the first few examples on differentiation. Differentiation is a branch of comes from a branch of mathematics known as calculus, alright, discovered by Newton, I believe. And without much further ado, I'm just going to give you a couple of questions to show you the method of differentiation. In class, we're going to discuss further, okay, what differentiation actually does for you. But for now, let's just get on with a few questions. First, I'll get on with on page 358. Okay, questions 1A, 1B, 2B. Let me write it down for you. 1A, 1B, 2B, 3C, and 3E. Okay, before I even get on to what differentiation is, I must at least get on to how differentiation works out. Okay, for example, if we have a function y equals to a, which is a constant, x to the power of n. When you differentiate, okay, this thing is called the first differential. First, what I do is the power, okay, I take down the power and multiply the constant a, so it's a times n. Sometimes a is 1, and I reduce the power by 1, n minus 1. Okay, so that is the basic method on differentiation. Now let's start with 1a. 1a tells us to differentiate 3x to the power of 7. So now to show that we're differentiating, we'll actually write dx. Okay, this means that I'm differentiating with respect to x. Okay, differentiating with respect to x, 3x to the power of 7. This is 1a. So first thing, I take down the power, so it's 7 times 3, so I get 21. X, 7 minus 1 gives me 6. 21 to the power of 6. So we learn two things. First, this simple shows that I'm actually differentiating. It's like, when you take the cosine of 50 degrees, I write cos cosine. This dx, right, means that I'm differentiating a function. Next one, 1b. 1b, they tell us to differentiate 5 over 2 x squared to the power to the fifth root. So first I'll write down, I will differentiate with respect to x, okay, 5 over 2, okay, 5, the fifth root of x squared. Okay, here's where we have to revise a bit on our laws of indices. If you remember, okay, what we actually do here, for the fifth root, I can actually rewrite it as x squared to the power of 1/5. Okay, that's the fifth root. Laws of indices. Now, I will start differentiating. So I take 5 over 2. I will multiply to the, the power here is 2/5. Okay, sorry, x squared. I simplify. So it's actually 2/5. So I've not differentiated yet. So when I actually differentiate this, what I get is 5 over 2 times 2/5. Okay, then x. 2/5 minus 1 is negative 3 over 5. Power negative 3 over 5. I simplify everything. I get x to the power of negative 3/5. Further simplification yields 1 over x to the power of 3/5. If I want to actually express this in positive index form. Alright, and that concludes 1b. Alright, now let me go on to the next question, which is question 2b. Okay, 2b states this: differentiate which of the following. Okay, so the following is negative 4x cubed plus 5x squared minus 12. Same idea as we have done so far. I show them differentiating, so I say I differentiate with respect to x. Negative 4x cubed plus 5x squared minus 12. In this case, I just differentiate each one of them. Okay, 3 times negative 4, negative 12. 3, I reduce the power by 1, becomes x squared. This one, 5 times 2 gives me 10. 2 minus 1, the power gives me x to the power 1. And 12. 12, right, actually, if you look at it, it's actually x to the power of 0. Okay, so when I take down 0 times negative 12 becomes 0. The whole term will just disappear. So I will get negative 12x squared plus 10x for 2b. Next one, I will cover 3c. 3c, again, they tell us to differentiate with respect to x. 9x squared, okay, minus 3 over x squared. Here is where we have to manipulate a bit because of this x squared over here. So what I do simply is this. I will differentiate with respect to x. I rewrite this as 9x squared minus 3. I express it in negative index form, okay, so that the x is in the numerator. I start differentiating. 2 times 9 gives me 18. 2 minus 1 gives me 1. Here, negative 2, I take the power down. Negative 2 times negative 3 gives me positive 6. Negative 2 minus 1 gives me negative 3. If you want to express this in positive index form, you can. I get plus 6 over x cubed. And that is 3c. Final example, okay, before this first set will be 3e. Okay, now 3e. 3e, same thing, they tell us to differentiate 3x plus 2 root x minus 3. So once again, I say I will differentiate with respect to x, okay, the whole thing, 3x plus 2 root x. I can write it as 2 to the power x to the power of half minus 3. Now very quickly, 1, then x to the power of 1 minus 1 is x to the power of 0. That's why the x just disappears. Here is 2 times half is 1. Okay, x half minus 1 is negative half. Number you differentiate 0, x to the power of 0 times 3, the thing just disappears. So now I just write it down in positive index form. It's 1 over x to the power of half, and I'm done with 3e.